So we have this electric field strength problem between two parallel plates. A charged particle is being accelerated between two parallel plates with a distance 12 centimeters apart and a voltage of 240 as shown here in the diagram. So here are the two parallel plates, the electron sitting in the middle of the plates, and one plate is receiving 240 volts and the other one has 0 volts and the distance 12 centimeters apart. Part A of the question asks us to calculate the electric field strength between the plates. So first of all, we know that electric field strength is defined as the force exerted on one unit charge. So for example, this electron sitting in the middle of the plates, the electric field would simply be the force exerted from the plates onto the electron. Just a quick revision, we should know that electric field is constant throughout the plates, so it looks something like this. And also we should note that the field flows from positive to negative, so the field is actually flowing this way. So we're writing down the equation for electric field. So electric field strength equals to force, in this case applied to the electron, divided by the charge being moved in coulombs. In this example, we are only given a distance and a voltage, so we want to derive some other formula for our electric field strength. So we know work done equals to force times distance, and we know that from our electric field equation, force equals to electric field times the unit charge, and we will call distance just d. And we also know voltage is defined as work per unit charge, so this would be V equals to W on Q. So if we rearrange this one, it is W equals voltage times unit charge. So now we have two work equations. We can equate them together to get EQD equal to V dot Q. So electric field, we divide both sides by the unit charge, and we divide both sides by distance. We have voltage on distance, and this formula right here is another way of expressing electric field strength, which is just the voltage divided by the distance. So we can use this for part A. So now we know our electric field strength can also be expressed as voltage on distance. We can answer part A, because remember we were given the distance apart and the voltage, so our electric field strength is 240 volts, and we convert 12 centimeters to meters, so it would be 0.12, and this would be 2 times 10 to the 3 volts per meter. That's our electric field strength. For part B, what force is exerted on the electron midway? We know that force is just simply EQ from here. We found electric field strength, which is 2 times 10 to the 3. And also from our tables, we know the unit charge of an electron is 1.6 times 10 to the negative 19 coulombs. So this comes out to be 3.2 times 10 to the negative 16 newtons for our force. For a proton, it would experience the same force as the electron, but in the opposite direction, because the charge of a proton is positive while an electron is negative. And that's the answer to part C.